Good day. For those of you who do not know us, we're the instructional staff for ECE 150, Professors Hiran Patel and Werner Dietl, and Douglas Harder. In this topic, we're going to give an introduction to classes. So, in this topic, we are going to describe issues that arise when we're using only primitive data types. We will look at examples where simple local variables are simply insufficient to solve larger problems, and we will introduce the idea of aggregate data or classes to solve this problem. Up until this point, we have discussed various different primitive data types, and we can declare local variables or parameters to be of these types, be it char, short, int, long, float or double, or bool. Now, in reality, most complex objects require more than just one of these values to describe them. Like, at this point, even now, every time we have sent an array to a function as an argument, we must also send the capacity as a separate argument. Let's look at a different example. Suppose we want to create a triangle for a graphics package. So we will want to create this element for a tessellation of an object that is to be rendered in an image. Now, such a triangle is going to, first of all, have 3 corners. And every single corner is going to have 3 coordinates associated with them. Additionally, each triangle will have a color associated with it, and the color itself has 3 different values: red, green, and blue. So that's a total of 12 variables just to describe one triangle. Now, suppose that we now author a number of functions to render or manipulate such triangles. So therefore, each function could have up to 12 parameters, the first 9 being the coordinates, the latter 3 being the color. Now suppose we add transparency to this triangle. Well, now we've got to update every single function, and consequently, we'd also have to update every function call to ensure that we are now not only passing what we've currently passed, the coordinates and the color, but we should have to update it to include the transparency. Now suppose we want to create a simple surface. Alright, here we have 11 triangles, which is a total of 99 coordinates, 11 colors, and 11 transparency levels. We could potentially store this as a number of arrays, but then we've still got to pass a number of different arrays. After all, while the coordinates may be double or float, the colors and transparencies are more likely to be int or even unsigned char. Now, suppose after we've written all of these various functions to manipulate such an object, let's suppose we want to add a fountain fill to every single triangle. So this allows the color to vary from one corner to the other based on 2 different colors and an angle. So now every single triangle requires a direction, so the direction of the gradient, and a second color, so the color that we're going from and the color we are going to. Now we've got to go back and update every additional function to deal with that again, changing the parameters and then making sure that the appropriate parameters, arguments are passed to those newly defined functions. Now, such tessellations are actually the basis of most rendered images. As we can see, by one here created by Gilles Tron, an agricultural engineer who specializes in such graphics as a hobby. You can consider how much data is required to create such an amazing and realistic image. Now, also one other point. Notice that color is something that's actually independent of a triangle. So, does every object that has a color need to deal with those colors independently? Hopefully not. Suppose also you wanted to create a Marks Manager application. So, therefore, every student is going to have a given name, Saeed, and perhaps a surname, like Inzaman ul Haq. They're going to have a UORLU student ID number, and that should actually be a string, because you're probably never going to add or multiply a student ID number by any other value. They'll also, of course, have a user ID for their email address, such as INZI. And they will have a program. Now, not only will students have information about themselves, but they're going to have a list of 0 or more courses which they have taken. So, for example, this person may have taken a course with a subject ID of ECE, a subject number 150, a term in which that course was taken, and a grade, 71 not out. Now, all of this data for all these students would have to be stored in arrays, and something we haven't discussed about yet, arrays of arrays. Then we'd have to author a number of functions to calculate, for example, term averages and overall averages. So much of this data would have to be passed to these functions to determine the current status of any one student. And again, suppose after we've developed this code and written all these functions, suppose we want to add, after a few years, a grading designation. That is, only some of the courses taken in any one term actually count towards the term and cumulative averages. Once again, we'd have to modify every single function that would require this information, and all of these function calls would require equivalent changes, adding additional arguments that therefore have to be passed. That's going to be a lot of work. And again, there's certain rules. Engineers cannot have more than 3 failures. Okay. However, or at least uncleared failures. However, while updating grading designations, the programmer may forget to update such code, as 3 failed courses only count if those courses themselves count towards the averages. All right. Additionally, it's possible for programmers to make mistakes. Again, all of these arrays can be modified by any programmer. So it might be very possible for someone to accidentally assign a grade of 110. I'm sure some of you wouldn't mind that mistake. What happens if the course was ECE 150, but the course was recorded as ECE 155 instead? Are there any checks for this? Well, no, because anyone could assign such a string at any time. So essentially, there's no way to check this. Any user at any time can modify any entry in any of these arrays. For example, suppose that the user accidentally wrote the following. So if courses taken N, is assigned the value 0, well, wait a second, what does that do? Well, that's actually going to assign the nth index of that array the value of 0. So now the student has taken 0 courses, but 0 is false, so we'll jump into the alternative clause, and we're going to calculate the overall average, although at this point the number of courses taken is actually 0. This is going to cause a problem. How do we catch that? Might be difficult. So, to solve this problem, we're going to introduce the idea of classes. Classes are a means of aggregating and protecting data. Now, the word aggregate means a whole formed by combining several, typically disparate elements. Disparate means significantly different. So, any such type is a collection of member variables, each of which is either a primitive data type or they themselves can be of other classes. So, an array technically is also an aggregate data type because it stores multiple copies. However, all of the entries of a particular array must have the same type. In a class, every single member variable can be given a different type. Consequently, any local variable of that type allows each member variable to have different values and can be assigned separately as necessary. And like variables of type int and double, they can be modified and they can be passed to functions. Instances of classes can have their member variables modified, and yet they can be passed as a whole to a function. So if you add additional member variables to such a type, they are automatically passed to any function that is past those instances. That's actually quite nice. So, following this topic, you now understand some of the issues with primitive data types. For large, complex objects, it's just too difficult to maintain all of the information in different local variables that are simply of primitive data types or arrays of primitive data types. For this, we need user-defined aggregate data types or classes. And so in the following section, this is what we will be covering. How do we declare and use classes to describe aggregate data? Here's the references, the colophon, and a disclaimer. Cheers!